We know that f of x equals x squared is not a one-to-one function. How can we restrict its domain so that its inverse function is g of x equals the negative square root of x squared? Again, we'll look at the compositions f of g of x and g of f of x. If we look at f of g of x, this is going to be f of the negative square root of x. And so that's going to end up being the negative square root of x quantity squared. And the negatives end up canceling out, giving us the square root of x squared, which is x so long as x is greater than or equal to 0. With g of f of x, this is going to be g of x squared, which is going to be the negative square root of x squared. And we want this to end up being x. However, we need x to be negative because when we take the negative square root of something, the result has to be negative, or technically 0. If x is 0, that's fine. But x can't be a positive number because we can't take the negative square root of something and end up with a positive. So the restriction that we have here is that x has to be less than or equal to 0. Now, it might seem like these two things are in contradiction to each other, but I promise you they're not, because these are the domains that we're looking at for two different compositions of functions. And what we need to know is, what is the restriction on f of x to make this work? Well, in this case, the inner function here is f of x, and in this composition, we said that we need x to be less than or equal to 0. So if, when we're substituting something in for f of x, we're substituting in something that's less than or equal to 0, we end up having this composition work out. And so in this case, our function f of x equals x squared needs the restriction that x is less than or equal to 0. This also ends up being fine in the first composition, because when we look at f of g of x, notice that g of x is always going to be less than or equal to 0. This is never going to be positive, so we're already taken care of in this situation that we are never inputting a positive number into f. So in both of these, so long as the input for f is less than or equal to 0, it ends up working out. So the restriction here is that x must be less than or equal to 0 for our function f. It's a little bit confusing, but it will make more sense when we look at things graphically next class.